Hi everyone, this is a video showing you Practical 2, making a map from my Introduction to Spatial Data and using R as a GIS course. So remember you should have the practical instructions open and I will share my RStudio window now. So we've got some existing material from Practical 1 and we're just going to carry on from where we got to. So far we've created some maps, but we've only done a few lines of code. And at the moment, we've just typed them into the console, which works. But as we get more complex maps, we need to do more lines of code. And so an easier way of doing this is a script. This allows us to type in multiple lines at once and run them as a block rather than doing one line at a time. It'll also allow us to go back and correct lines of code as well if we get it wrong. So we can start a new script in R, so file, new file, R script, and it will open this new tab at the top. And this is our script. So this is where we type stuff in now. So we're going to work on this for this practical and create our map from in here. We're going to work with a variety of data. So we need to download a bit of data. So I'm going to swap to my web browser so you can see that. So here's our workbook, and we're going to work on the Nomis web. Actually, I will move that over there. Excuse me while I shuffle my windows around. Here we go. So Nomis is produced by the ONS, Office for National Statistics, and we can download a bunch of data from them, particularly census data. So if we scroll down to census statistics, 2021 data catalog, so data from the 2021 census, and then bulk data downloads, wherever they happen to be. Here we go, right at the bottom. And we are interested in age by 5-year bands. So this TS007A file. Make the window slightly bigger and scroll across. So we can download this as a zip file. So we save this into our folder that we have. So we should call this intro R prac 2 because we're on practical 2 now. Let's rename it intro R and save it in there. And we will also need to extract it. So I will show you what the files look like. So it's a zip file. We need to select it, choose extract, and make sure we put it in the same folder, not a subfolder. And we've got a whole bunch of CSV files. So you notice they're all census 2021 TS007A, which is the table we're interested in. And then they're by different geographies. So we've got CTRY, country, LSOA, lower layer super output area, which is what we're using, local authority, middle layer super output area, region, and unitary authority, I think that is. Anyway, we are looking for the LSOA file. And if we open that up in Excel, I'm not going to do it on here, but you see your columns, lots and lots of columns of data. And we can read that into R, which is what we're going to do next. RStudio. Here we go. So we can read in our data. So if you do pop 2021, create a new variable, read.csv. So read in a CSV file, and then what's it called? Census 2021. If you press tab, it will try looking in the working directory, but we need a different directory because we created a different one for our practical. So practical 2, and then we can choose set working directory from there, and it will update our working directory for us. And now it's given us the list, and we want LSOA. So let's select that. Now, if we just press enter, it will put a new line in our script, which is not very helpful. So we see what it's done. We just do Control Z to undo. We can use Control and enter. So hold down the Control key press enter, and then let go, and it will run that code for us. And it's read in our POP 2021 data. If we do head POP 2021, control and enter, it will show us the data. And so we'll make that slightly bigger. You can see we've got our date, geography code, and then various columns. So total number of people and for the different 5-year age groups. It's worth mentioning it's good practice to add comments into our code. So we'd use the hash symbol and say read in population. And this is partly for you now, partly if you share your code with someone else, but also partly if you come back to your code in 6 months' time and think, what on earth does that line do? You've got a little note that says this is what it does. So you may have seen that these column names are not great. We need to rename those. And we've got a bit of text in the workbook to do that. So if you copy and paste that in, and it's creating a new variable with all of these column names in. And of course, we need to run it. So another way you can run code is highlight it and then click the run button. And what essentially it does is copy and paste it into the console. And you see we've got this new column names variable that's been created. So we also need to check. So how do we do that? Hopefully you've spotted that. It's the head function. So head pop 2021, but we haven't actually applied the names yet. So before that, we need to do our second line of code. So col names pop 2021. And now we can say, okay, which columns? So we do square brackets and colon. So this is saying columns 4 to 22. So take all those, and these, if we just run this, will give us the output. If I spell col names correctly, plural. Here we go. So these are the columns that we're going to change. And we're saying, okay, so assign the new variables new col names. And if you do that, you should have updated the column names. And our way of checking that is the head function. So it's much neater, much tidier, they're much shorter, and we can work with them a little bit more easily now. One other thing it's worth saying is you should also save your script regularly. So you see it says untitled 1 at the top here. That means this is not saved. So if computer went off, crashed or whatever, I'd lose everything I've got in here. So we choose save, and it will put us in our working directory, and we're going to call this script. You can call it whatever you want, but something obvious is a good start. And so now that script is saved. So if we wanted to rerun the code, it would be there for us. So we've got our age data, but we also need our spatial data. So for this, we're going to go to census.edina.ac.uk. I will swap screens again. Okay, and this is not found. With this, I need to update the URL. So I think from memory, this is borders.ukdataservice.ac.uk, and I will update that in the script in the workbook. Boundary data selector. Yeah, and then set country to England. Geography to statistical building block, and dates to 2021 and later. And we want the LSOAs, lower layer super output areas 2021. And if we click list areas, so at the moment, this will be for the whole of England, which would be fine if we wanted to do the whole of England, but we're just interested in Liverpool. So select England and choose expand selection, and it will drill down 1 level. So these are the government office regions. So we want northwest, choose expand selection, and then within that, we can choose Liverpool. So we could drill down further if we wanted, but we want the whole of Liverpool. So we just select Liverpool and click extract boundary data. And Borders will sit there for a few seconds and download it. And here it is. And so we've got our zip file, and we're going to download that and save it in our working directory. And we are also then going to extract it. Exactly the same process as we did previously, remembering to put it in that working folder. So if we swap back to our studio, here we go. And we can see it's already updated. We've got our England LSOA 2021, which is what we just extracted. So let's read in the shapefile. And again, we can use the autocomplete to choose the .shp. Let's read it in okay. Yep. And then we can use exactly the same as we did your QTM to do us a quick preview of the map. Yeah, and that looks right. That's Liverpool. And we can use head as well, exactly the same as we did with the St. Helens data. Yeah, and we've got our codes, names, and the geometry column. Cool. So we're going to join the data again. So we're updating the LSOA layer, and we're using the merge function. So we're merging LSOA and POP 2021. Okay, if we look at the data again, our POP 21 data has its geography.code is the code we're using to link the two. And in our LSOA data, we're using the LSOA 21 CD. So R is not clever enough to work out which columns because they've not got the same name this time. So we have to explicitly say. So we're going to say by.x equals LSOA 21 CD. X is the first data set. So in this case, it's from the LSOA data set. And then we'll say by.y equals quotes geography dot code. So this is going to say, okay, take the LSOA 21 CD column from LSOA and the geography.code column from POP 2021 and use those to link the data together. And let's run that. No error message, that's a good start. And we'll have a look using the head function, and it will show us the first 6 rows of the data. So this is looking good. We've got our code, we've got our name, and then we've got our total, so total number of people, and then the number of people in each age bracket. So that's looking good. Cool. So remember to save the script. It's worth mentioning when you save the script, all it does is save the script. So it doesn't save any of these variables. This works reasonably well. So if we wanted to recreate it, we'd have to rerun the script, and that's fine. So how do we do a map? We can use the QTM function like we did earlier. So have a go at that if you want to. If you want to have a go, pause. Otherwise, I will carry on. QTM doesn't give us much variability though. So we can use the TM shape function to do a bit more with this. So this is TM shape LSOA. And TM shape always has multiple parts. So we're going to do some polygons, and then we say what column do we want to show in the polygons. So we're doing age 0 to 4. If we run these, it will do that 2 lines as a block, and it will give us a map. So here is how many people there are age 0 to 4 in the different LSOAs across Liverpool. And then we've got some areas where they've got quite a large number of 0 to 4-year-olds, and other areas where they're quite low. And we can do this for any column that we want to. So this, this is pretty similar to the QTM output, but we can add extra options. So the next example is we can add a few more bits to this. So we still use the LSOA, but we add some more stuff to TM polygons. So we still got to say what column we want, but we can set the title. So we can set the title to be age 0 to 4. So make it look a bit nicer. We can set the palette, so that's what colors we want, to greens. We can set the style. to Jenks. And that will give us some a map, and we can add some other bits as well. So we have TM layout, where we can set the legend title size. So here we're going to set it to 0.8 to make it a bit smaller than the default being 1. If we run that, so we say we've got these green palettes, legend title size is a bit smaller, and we've got the Jenks classification rather than the default, which I think is pretty. And then you can have a go at substituting different colors and classifications and so on in there as well. So if you want to do another map, we can just change this to say blues and then run the thing again, Control and Enter. It'll recreate the map with blue color scheme instead of green. We can also change how many classes we have. So the default is 5. If we put in n equals 6, we can add this parameter. So this is a bit of information that goes into the function. Run it again, and it'll redo the map with 6 classes. So there's lots of different options in terms of colors, number of classes, and how we split the data up. Have a check of my book or other resources on the website if you're interested. If you're doing this course with me, we'll do a little exercise and talk a bit about the different options and the pros and cons of the different ones. One really useful way of looking at the data can be a histogram. So we can do this in our studio. So I'm just going to copy and paste the code into here. And so we pick out our variable, load the class int library, calculate the breaks. So this is now doing the math to say, okay, we want a Fisher style breaks with 6. And if we look at the breaks variable, there's quite a bit of information, but it gives us the boundaries. So 5 to 45.5, 45.5, 47.5, and so on. So we can do a histogram, the data, and then we can add these lines. So these are where the class breaks are. And we can also add a histogram to the map as well. So one of the options in TM polygons allows us to add a histogram. So this is this legend.hist equals t. If we run that, do the same map, but add a histogram in. We'll have to faff about with the layout, and we'll get to that in a bit. So there's various different layout options. What you'll need depends on your data. So you can see here the histogram didn't really work because it moves up the legend and it covers part of the map. There's various options in terms of margins and so on. Definitely have a look at the TMAP help for this because it is very good. It gives you a lot of information. We can also add scale bar and north arrow. So we've got some code in the workbook. So the few bits going on here. So TM shape and polygons is exactly what we've done already. The scale bar is this line here. So it's a scale bar. How wide do you want it? And then the position is where on the map you put it. So these are values between 0 and 1. So firstly for left or right. So this is on the left-hand side. And then top to bottom. Bottom being 0, top being 1. Ditto for the north arrow. Same sort of principle with the position. And then we've got some extra frame layout stuff. So we can turn the frame off. So that's the box around the outside. We can give it a title, change the size, and so on. And if we run that, we can see it puts out the map like this. Okay, so we need to shuffle stuff around a little bit. So let's move the title to 6, see if that moved it over a bit. Okay, so it's moved it over a bit. Let's try 6.5. So that's halfway between 6 and 7. It's probably all right. It's a bit close. Let's try 6.7. Oops. I delete the comma. So let's put the comma back in, see if that works. There we go. And the scale bar is in the way as well. So, you know, we could put it below the legend, we could put it above the legend. Let's move it up a little bit. So that's this 0.18. So let's try it 0.20. It's moved it up a bit, but we need it a bit more. So let's try 2, 5. Oh, that's gone a bit too far. So let's put it down as like 2, 2 maybe. I might do it as 2, 3. And let's move it over to the left a bit. So change that to 4. So you can see this is quite an iterative process. You change the code, you run it, see what it looks like. So we can fiddle about with this a bit. It's worth saying that you'll need different numbers depending on your screen layout, screen resolution, and that sort of thing. So have a fiddle, but try not to spend too long on doing this sort of thing. So we can do interactive maps as well. The TMap library allows us to do this. So again, I'll just bring the code in from the workbook. So the default mode for TMap is plot, which is what we've been using, and that's the kind of normal one you'll use. If we change it to TMap mode view, this allows us to do interactive maps. But we've still got to tell TMap, okay, we want to do a map. So we can use the QTM function, and it will give us, so you can see this, and if we can click on the different polygons, and it will tell us, so this is St. Helens and the burglary data, and you can zoom in and out. So you can see where St. Helens is relative to Liverpool and the rest of the UK. This is actually a leaflet interactive map, and that's what it uses behind the scenes to do this. We can use this with TM shape as well, and all the stuff we've said about the polygons, the classification, the color, all that is still relevant on here as well. So we can run that next bit of code, and here's the Liverpool data. We've got a nice legend. We can mouse over and it'll tell us what the codes are. We could change that to names if we wanted. If we zoom in, we can say, okay, let's have a look at this LSOA, and it'll tell us there's 1,600 people in this one. If we zoom out again, we can have a look. You can also turn layers on and off if you want and have different base maps. And there's lots more you can do with this. So have a look at the help. We've got to return to plot mode for normal maps, and it's always good to do that so you don't unexpectedly get an interactive map. It's also worth mentioning there's the Shiny tool that allows you to do more of this online, so well worth having a look at that as well. So the last bit we're going to do in here is looking at loops. So we're going to use loops to create multiple maps. And this is one of the big advantages of R. Because we have this scripting environment, we can use the concept of loops to say, okay, create me 10 maps, one for each column of data. So the first step for this is, rather than saving the map to our plot window, which we've just done, we save it to a variable. So this code is exactly the same as what we had before. And if I just run this, it will run the highlighted code, and this will just plot a map in our plots window. There we go. And you can see we've got the layout wrong as it was earlier. You see in this line here, we do assign to M. So if I run this now, it will run that block, and it still creates the map, but this time saves it as a variable called M. And you see that's come up here, large tmap. The key bit is it will only save it as that variable. It will not show anything on the plots window. So if we change this to blues, let's say, then run it again, you might think nothing's happened, but it still has updated the map, but it's just not shown it on the screen. To save the map, we then use tmap save. And this will take our thing called M, and it will save it. And if you go and have a look in your working folder, it will have created a file, tmap01, and it will have saved the map there. And I've had a look, and it is there for me, and it's come up with a blue map. And the layout is different as well. So that's the first step. So how do we get into loops then? So there's the next chunk of code is in the workbook that does the loops for us. So I will put it on here. There is a separate video where I talk in more detail about loops. So if you're interested, check that out. I'll add the link below. But I'll go through it here. So our first bit is this map variables. So this is what columns do we want to show? So here we're going to say we want the total population, age 0 to 4, and age 5 to 9. but this is up to you. You can have 5 columns, 10 columns, 100 columns, doesn't matter. And then the loop itself is this 4 section. So you see 4, and you may have noticed there's a little down arrow here. If we click that, R will collapse the whole loop. It gives us a little symbol here to show that there's more code. And this can be really useful if you're dealing with really big scripts. So we have 2 kind of main chunks for the for loop. So the bit in round brackets, which I'll get to in a minute, and then the bit in curly brackets. So the curly brackets is the code that it actually runs. And so this is what the loop will do every time you go through it. And then the round bracket is how many times it goes through the loop. So it creates this thing called I, called an iterator, and we use that later. And it says go through the loop 1, 2, however many times. And so this is saying length map variables. So how long is map variables? If we run that, it's saying, at the moment it can't find map variables because I haven't run that bit of code. So we'll run that, and then we'll run length map variables, and it says there's 3 things. So this is going to go through the loop 3 times. The code in the loop, so this stuff is more or less what we already had. So TM shape, LSOA, TM polygons. Instead of specifying which column, we're going to say use the map variables. So on the first go through, this will be 1, and it will do the total column. Second, it will be age 0 to 4. Third, it will be age 5 to 9. And then palette green style equals is the same. Scale bar's not changed. Compass not changed. Layout's not changed. That's all identical. And then we have tmap save. But this time we have to change the file name each time, because otherwise we just create 3 maps but overwrite each time, which is no use. And here we're going to say use map variables and a number, so whatever column we use, and save it as that file. So let's run the whole thing. With the loop, you always have to run the code all together. You can't do it 1 line at a time. You have to do it as a block. And so you can see the output RStudio is giving. So it's saying done map total, map 0 to 4, map 5 to 9. And they should all be in your working folder. So if you have a look, you should see that the 3 maps are there. And they'll be different because they're different data, of course. Last exercise, this is an optional one if you want to have a go. So far the title is just using the column names, but can you change the title for each one? So have a go with that. There is an example in the scripts data, but try not to look straight away. See if you can experiment with the code and have a go with that. That brings us to the end of Practical 2. Thank you for watching the video. Practical 3 is up next. Please do check out the website and my books and my training courses if you want to know more. Thanks.